Welcome to the Align Project's Year 1 Seshat demonstrator video.
Seshat, the Global History Databank, is a massive database of historical and archaeological data. Its purpose is to be able to see the macro patterns that characterize historical processes.
Seshat is attempting to harvest all known human knowledge about the evolution of social complexity through a global collaboration of teams of scientists. A wiki was used to collect the initial Seshat datasets based upon a sample of 30 natural geographic areas selected to provide a broad variety of data. Within each natural geographic area, or NGA, every political system which was present in the area during the last 12,000 years is identified. Variables describing the characteristics of these polities are encoded using a special syntax defined in the Seshat codebook, which allows the expression of uncertainties, disagreements, and time ranges. To date, the Seshat research effort has collected some 85,000 data points, covering 551 polities within the 30 selected NGAs. Research assistants are given the task of encoding variables for a particular polity using traditional social science techniques. Their encodings are then checked by recognized authorities on the area in question, who also, where possible, fill in variables that the research assistants were unable to. The wiki was an ideal choice for the pilot phases of data collection, but as the project has grown, its limitations have become apparent. Encoded variables can become very complex, and it is easy to make mistakes. Complex values are harder to encode, so users will discard complexity in the evidence. The codebook is constantly being updated to incorporate new findings from social sciences. This means that the polities which have already been encoded must be manually updated. As we are dealing with long-term historical and archaeological data, we must handle great variability in scope and reliability of data. A large dataset makes it more difficult for people to understand the patterns in the data. Maps, charts, and other visualizations are needed in order to allow them to grasp the patterns in the data. In Aligned, we are combining traditional model-driven software development technologies with emerging linked data technologies to more effectively allow dataset managers to tackle the most common issues encountered. We have produced a trial system for Seshat which combines model-based engineering and linked data approaches to address these challenges. The first step is to define a formal knowledge model for the Seshat dataset. This formal model will allow us to analyze, validate, and correct the collected data, identifying syntactical and semantic errors. Effectively developing knowledge models requires input from multiple stakeholders over extended periods of time, particularly when the model is in constant evolution. In Aligned, we are extending Oxford's model catalog tool to handle semantic models.
Every old-school programmer or data manager knows the value of a data dictionary. What does this value mean? How is this variable used? This information needs to be communicated. Without this communication, collaborators tend to drift apart. These days, programs and data add up to the same thing, so we need data dictionaries more than ever. But the number of variables, values, terms, identifiers, fields, let's just call these data items, that we use has increased exponentially. We're no longer looking at tens of data items, we're looking at millions. So we consider collections of items and we consider relationships between these collections, and we automate as much as possible. To make this automation work, we need to organize our collections in a standard way. We organize them as data models using a common language, a common data modeling language. And we need a toolkit. We call this the model catalog. And here it is.
In order to use these knowledge models in practice, we must deploy them within a workflow which ensures that incoming data conforms to the models. In order to achieve this, Trinity's Decura system provides ways in which data can be processed by human and automated tools. At the core of this workflow is the Decura Quality Service. This checks both ontologies and data in order to ensure that they are consistent. It can flag inconsistencies and errors for further review by data managers. After defining our model as a formal OWL ontology, the next step is to integrate the wiki with Decura's REST-based data quality service. Our initial deployment of this service performed simple syntactical validation. This was deployed fully in March 2015 and saw a rapid reduction in error rates. The next step was to deploy the new Seshat owl ontology. The Dakura system uses this ontology to automatically generate user interface elements, which are designed to prevent any possibility of syntactical error. These user interfaces also reduce the difficulty of expressing complex variables. Align's Dakura system provides the Seshat project with tools to handle their increasing complexity. Dakura widgets allow easy entry of complex data, reducing the chance that it will be discarded. Schema management with the model catalog tool allows them to track revisions to their codebook, and our consistency checks allow them to handle the wide variety of data they draw from. In this video, we have shown how the aligned research and tools have been deployed to address the challenges of the Seshat project. Stay tuned! We will be releasing another demo in early 2016, outlining further developments in the Seshat toolchain.